Hi, Nikhil. Okay. Yeah, still the same. Still the same. We'll tell you the 244 Mike Golf Papa. Yeah, just a moment. Mm, okay. Mm-hmm. Okay. Let me also monitor the live session here. I will volume low. Yeah, otherwise it will got a feedback. Yeah. Okay, I will mute the speaker. No, only for that YouTube video. I will only. Who is that? Is that my own voice? No, I heard some like somebody speaking, but it could be my own voice echoing. Okay. Okay, I almost forgot something important. Water. Is there a way to say, to tell like how many people is watching currently? Okay. Okay. Mm-hmm. Sure.
Hi, everyone. Welcome to our live stream. We've continued our Saturday tradition online. As you can see, I'm not at the lab this time. We are obviously in a different situation and we are complying with all as should everyone, with all the authorities' requests to stay at home. So we hope you're staying at home. And while you're at home, we hope to keep you entertained with what we are going to be doing there today. You've seen the description already. Today, we are going to have another guest workshop. This will be somebody who was there, who was part of our last Arduino day and did, present during that. And he is going to be expanding on something he mentioned briefly on Arduino day. This is Dr. Judhi Prasetyo. I will introduce him in a bit. But of course, for those of you who are first timers, I want to also show you a little bit about the assembly. So I am going to actually just quickly go over. Let me just switch over to this mode. And I'm going to quickly go over what the assembly is so that you are aware completely of what you are watching, if in case you've just joined. So yeah, the assembly is a smart lab that's based out of In5 since December 2014. We've been around as long as In5 has been, almost, just give or take 6 months. So we've been supported by them right from the start. In5, of course, is the startup incubator for Dubai Internet City. So we've been doing free workshops, all in person, for the last 5 years. We've done over 250 free workshops. We maintain a very punishing for us schedule of doing one every week, and we make sure that the content is constantly fresh so that we keep changing from topics. We don't claim to be a training institute per se, but we are more of a system where we give you a push into different types of technology. So workshops like today, where we work with embedded systems and IoT and hardware, those come under the assembly hack workshops. But we also do assembly code workshops where we work purely with software APIs and frameworks and apps, and where you don't need to use any hardware. Though if you do need to use hardware, like in the hack, when you attend our live sessions, we provide all those for you. In this case, obviously, since it's online, you will have to get your hardware yourself, but it is quite easy and accessible. We don't use anything that is too expensive to acquire or too difficult to acquire, most of them are available locally, and most makers would have that. We've also launched a data science a data science stream where we do data science workshops. We did the last one before the crisis hit. Actually, just as the crisis started, we did it online. And we are going to continue to do those as well. Our target audience is all around students, professionals, entrepreneurs, and we focus on practical applications. You can check out our forum. Our forum is where we put all the information, and we also, of course, manage our RSVPs. Just a quick note, we are very active on social media. You can find us at Make Smart Things. That's our mission statement, as well as a social media handle. And today we're streaming it actually on Facebook, Twitter, and YouTube, in addition to our site. So please join in from any platform that you prefer. We are going to, during this interim, we are going to experiment with different formats. So we have been of course, this workshop, as you've noticed, we've kept it to about an hour because we believe that is the optimum time that it would take for people to follow on properly. And we will experiment with even shorter formats, as well as content that we will share. We're not going anywhere. We are going to be constantly sharing content with you. Our team is working from home, but we are constantly making and recording content that people can see. We might try more interactive formats also. We have another workshop scheduled for next week, which we will give you details of after this session ends. So I'm just going to come back to my stream there. Okay, so let me just check if Professor Judhi is online. Professor Judhi, can you hear me?
Yes.
Okay, his mic is back on. I'm going to just bring up Professor Judhi on the stream as well. Let's have a look here. There you go. Hi, Professor Judhi.
Hi.
I don't know if you can see me.
Yes, good morning, Nikhil and everyone. Just Judhi will do. I think we are more comfortable like that, since this is not the classroom, this is a community. It's from us, for us. So let's do that.
Perfect. No, I understand, of course, that you are Professor Judhi throughout the week to all your students. Middlesex is, of course, continuing learning online. And I know that, fortunately, that helped us as well, because you are quite comfortable with the online setting. So we've been, I understand that you've been doing classes throughout the week. So we appreciate you taking your time and working with us on this and sharing with our community as well. So as I was mentioning earlier, this is something that you have worked with on your, this is something you mentioned last week during Arduino Day, and you showed Simone. So, and then after that, we came up with the idea that we thought, hey, that's perfect thing for the workshop. It is something topical. It's something that is, going on now that could be useful. And of course, a lot of people have thermometers and they are making good use of them and during the crisis, but it's nice to know how they work and how these things can be built up on their own, supposing we have a lot of shortages now, of course, of different types of equipment. So it's good to be self-reliant on the simple things at least. So just wanted to ask you, actually, how did you think about this idea and how did you come about this project?
Yeah. Okay. So first of all, thanks for having me in this very good opportunity. We seize the opportunity to do online session. And thanks to the Assembly for always organizing good things for the community. Okay, so to answer your question, how did I come up with this? Well, I think it's not the first time. I believe many other people also have the same idea. When they see about this virus, they will see first what are the symptoms, right? One of the symptoms is fever, and fever can be identified by head temperature. Most of us just put our hand on the forehead or here to measure the temperature, but that's not the good way of doing things. So we have thermometers like this to measure the temperature. However, this is very personal, and if you want to use it for many other people, you need to clean it up, right? You don't want to have things that is shared. So as you can see, probably in some like in some places like airports, they measure the temperature using a FLIR camera, an infrared camera. So this is also practical, but expensive. So we cannot easily get those kind of cameras. Then there is another way, which is measuring the temperature using this non-touch thermometer. we see this in some places, in some offices, where there's a guy standing with a gun-like thermometer, and they put on the forehead as if there is an execution, right? So, okay, so I think there is something like that. Yes, we know. And so it happened that I have a sensor for that. So I just try to come up to build it myself, because nowadays I think that kind of thing become expensive. I don't know, maybe it's a short of supply, or maybe because it is originally already expensive. We also know there are some thermometer that is you have to put it inside the ear. Usually this is for babies. So I think this is the same principle. So I have some slides that we are going to explain how that works.
Okay, Professor Judhi, I'm going to leave you with it. I'm going to just bring you up on screen and you can take over the show now. I will pop back in between, because I also have a few questions. And of course, I'm also monitoring our live stream. So in case people have questions, I'll definitely pop up and bring that to you. Of course, I'll let you know in advance. So I'm going to hand it over to you. I think you can, you're going to be on full screen now. Of course, just let me know when you want to start sharing your desktop screen as well. I know you've got a whole lab set up there. And I will also bring that up. Okay, you're going to be live on screen now, Solo, right now.
Okay. Yes, so I can share my screen right now.
Okay, I've shared.
Thanks for those who are joining. Yeah, please feel free to make this as interactive as possible. Again, this is not a classroom. This is a sharing session. So everyone is free to contribute, or everyone is free to interject or just ask questions. Okay, you can share my screen now. Is it sharing now, Nikhil? All right. So I just want to start with this basic principle of infrared thermometer. Usually people needs to have a contact to measure the temperature, like I mentioned earlier. Like if you want to measure the temperature with your hand, you want to touch that object, right? Or if you use a thermometer like this, you want to put it somewhere, right, in the mouth or in the armpit. This makes it unhygienic, and it takes time as well. So you can think of other ways in measuring the temperature. And one of the things is using infrared. This has been used in the industry for quite some time. For example, to measure something you cannot touch because of physically it's not possible or dangerous. For example, it's a molten metal, right? In the industry where you have a molten metal and you want to measure the temperature, of course you cannot touch that. Even if you put a thermometer on it, it will be melted as well. So the scientists developed something like this. It uses the radiation of the infrared that is emitted by everything that has a heat, like even our body. It will be projected, it will be hitting this sensor, and based on the amount of that kind of radiation, we convert it into the electrical properties, the electric current, and we can measure that. The higher the current means the hotter it is, right? The higher temperature it is. The thing with this method is it's not very accurate, but it is repeatable, means that it is consistent. Not very accurate as in it does not reflect the actual temperature of it, but every time you do it, you will get most likely the same result. So it's consistent. So what do we do in this kind of situation? Well, if you know that this is consistent, like if you are consistently missing on something, then you just need to have a compensation, or you just need to adjust the result so you have a more accurate result. For example, that kind of temperature sensor that you see using like a gun-like, when they point to your head, right, it has to be in a certain distance to produce a accurate result. And we will go in very detail later on. So now we are going to see the parts list. So sensor is not the only thing that we are going to do today. Other than sensor, we need to display that, right? Of course, this display is it looks nice like this. So I happen that I have it lying around, but I will start later by programming the Arduino, connect to the sensor with only 4 wires. But we are going to display it on the serial port first. Once this step is done, then we are going to connect the display and make sure that what we have in the display is consistent with what we have on the serial port. Okay.
Dr. Judhi?
Sure.
Sure. Hi, Dr. Judhi. Hi, Judhi. I want to make sure we stay informal. I just wanted to actually ask you a bit about some of the parts. The OLED display. First of all, I think all these parts you can get locally, right? Like, I mean, from our, I know like we usually depend on a lot of places locally that even deliver online. So, are they all available locally?
Yes, for those who watch this from Dubai or Abu Dhabi or in the UAE in general, usually I got my parts online, or sometimes I go there as well. We have friends in, by the way, it's not sponsored. Yeah, it's not a sponsor, it's not an endorsement, but I'm just sharing. These are friends in Edwin Robotics and in TechMaze in Abu Dhabi, Edwin Robotics in Dubai. You can also search for some of the shops like Besomi Green Electronics in the Naif area. I hope they still open, or maybe they do a home delivery in this kind of situation. I don't advise you to go out and buy. You can also try to shop from Amazon. Again, this is not an advertisement or endorsement, but I'm just mentioning some of the ways how you can get these parts. You can easily go to Google if you like and search like Arduino sensors online, Dubai, Abu Dhabi, or wherever you live. I know some of you come from other countries as well.
But that's a very specific temperature sensor, this MLX 90614. So that's as opposed to, I guess, the usual way where people use the DHTs and all that. Is it necessary to use this particular temperature sensor?
Okay, so the difference, yes, DST or NTC. DST inside actually is an NTC, which is a negative temperature control, right? So it requires some degree of proximity if it's not really touching.
Okay.
But you can't really use that to measure the body temperature, because then you have to be very close. If you get very close, then like you defeat the purpose of having a no touch or no contact thermometer. So that's the difference.
But even your like the OLED screen, are there other options we can use? I see you've got one. I mean, you've mentioned a specific one, but can we use other things? I guess even like
sure.
maybe if you want to keep real simple, even an LCD.
Okay, let me switch to my other camera. Can you see this?
Yeah, we can.
Yeah.
See.
Okay, so this is the sensor that earlier we discussed, and this is the OLED screen that I'm using. But we can also use other screen. Doesn't have to be OLED. For example, this is a very popular display. If you have Arduino kit, usually it comes with it. The difference is it's already fitted with the I2C converter over here that allows this display to run only on four. Sorry, something's happening. Okay, on four wires only, which I will explain why. So this attachment, the black board over here, is additional. I solder it myself. Well, some already sold like this, but usually the original kit comes with this kind of display, and then you attach this board and solder it, so you can use a 4-wire only. Yeah.
Great. I'm going to get out of your hair right now, and I'll leave you to carry on with that. Thank you.
No, it's okay. I mean, yeah, don't worry.
I'll pop back in a bit when we discuss.
Ask question anytime. Sure. All right. Okay. So I'll go back to the. Let's see. How do I go back to my? Okay. All right. So what I'm going to use now is Arduino Uno. Okay. Of course, we can use many other Arduinos later. We can discuss about that. But this is the most popular Arduino and easiest one to get out there. And then the display we have discussed. You don't have to always use this display. Even if you don't have display, you can display it on your serial port. And if you get creative, you can create your own display using your mobile phone. We can discuss later. And the temperature sensor, this is a very specific thing, yes. So far, I haven't found any other model that can do up to like a 40, 50 centimeter measurement without the degradation so much. All right. So this is the wiring diagram. As you can see, we only need 4 cables out of Arduino. And the first one, of course, is the power, the VCC. We are using we are connecting to the 5-volt part of the Arduino over here. We power the breadboard. And then we have the ground. Okay, these two are must. Oh, sorry. And then we have 2 cables going out from A4 and A5. You may recall A4 and A5 in Arduino serve as analog input, but in this case, we are going to use this as the SCL and SDA. SCL stands for signal clock, and SDA signal data for the I2C interface. What is I2C? Okay, it's a bit theoretical here, but I think it's good for you to know if you're interested. If no, if it's not interesting for you, you can go out and having coffee and come back in about 5 minutes. I'm going to rattle about this I2C. This is a very good thing. Yeah, the protocol, it really helps. So originally, you see that there's a lot of wires going out of microcontroller, but you don't want to always have that. First, it's messy. Second, well, it eats up a lot of space. Yeah, and of course, if we build a prototype, this will increase the chance for us to make mistake with so many wires. So they come up with this idea. Okay, instead of coming up with a lot of wires, why don't we come up with only 4 wires? We divide these 4. Okay, 2 for power. Positive and negative, or 5-volt and ground. And then we have SDA and SEL. So the idea here is all the devices are connected to the same bus. So this is like a bus. If you're in this field, like my third-year students, they are very familiar with I2C protocol. They can attach many devices into the same bus, and you have one master controller. In this case, it's our Arduino. The Arduino becomes the master, and the display will become one slave, and the sensor will also become a slave. So they are all connected through the same cable. So now you might ask, if everything is connected to the same wire, how does this know that the data is going in or out to the right place, right? Because everything is connected to the same place. So this works exactly like your home address. Your home is located on the same road, right, with your neighbors, for example. But your home has address. And that address is the differentiation factor that differentiate your place and other place. So each of these devices needs to have different address. So when the master, in this case the Arduino, wants to talk to the sensor, for example, it will listen to a certain address. So when other sensors talking, the Arduino will not listen to that signal. It only listens to this device. And also when, for example, the Arduino wants to write into a display, let's say this is the display, it will write the data to a certain address. So only the device that is standing by on that address will get the data and display it out. All right. I'm not going to be very technical, but if you're interested, you can go to this link or you can Google I2C protocol and you will see a lot of information on that. Okay, so I hope it's clear enough why we only need 4 wires, even for input, which is the sensor, and for output as well. So looking at the sensor itself, so let's program it. Maybe before we program it, we have to wire it up, right? So, okay, I'm going to wire it up. Let me switch to my other camera. Oops. Okay. So I have an Arduino over here. Okay, I'll put it there. I have a breadboard and I have the sensor. So sorry for the low resolution camera. That's the only one I have. I tried to get a higher resolution camera. I went to shops and I found that all of the webcams are out of stock, sold out, because everyone is trying to work from home. So, okay, bear with me.
Professor Judhi, before you start wiring, we just had a question come in online
Yeah.
from Amit Joshi. He's asking, like, how accurate would this be, the sensor, compared to what's used in the ear? So, the ones that are there. So, Amit wanted to know that.
Very good question. So, who was asking?
Amit Joshi. He's asking.
Amit Joshi. Okay, Amit, you asked a very good question. If you just stand by for another few minutes, I will discuss about that. Yeah.
Okay, great.
It's not very accurate. That's why we need to put some compensation.
Okay, so
details
you're going to modify it
coming
further. Okay, sorry, I'll let you get back to it.
That's okay. Okay, keep those questions coming, by the way. Okay, so I will wire this. First, I will wire the ground. Okay, ground is this one. I hope it's correct. Okay, ground. And then I will get the voltage in here. I think it's a good habit, to be consistent, like use the red color for the positive, use the black color for the negative. Of course, if you want to make your own standard, it's fine. But if you're going to share your circuit or your prototype with other people, it's better to use the common sense. Okay, and connect this to the Arduino. On the red, the black one goes to the ground. Okay, this is the ground, and then the red one to the 5 volt. Okay. Yep. Okay. Next is this part. Next is the SEL and SDA. All right. SEL goes to pin number 5, and SDA goes to pin number 4. Usually I on number 4, so that's the only thing that I have to remember. A4 is SDA. So I'm going to connect A4 to SDA. Yeah, SDA, which is this one over here. The leftmost part of the sensor is the SDA. Probably not very clear, but yeah, it says SDA. And then the SEL, of course, is the other one next to it. So very easy to remember. SDA, A looks like number 4, so A4 is SDA. There you go. Done. The first wiring. Now we will connect to our Arduino IDE. Okay, connect. Okay, now let's go to the Arduino IDE. I already have the code over here. Okay, Nikhil, are we going to share this code later on? I haven't got a chance to upload this to my GitHub, but yeah, I hope we can share this later on.
Yeah, we'll definitely share it. Whatever links are there, we will update it in the description, and we'll also share it on social media. So no worries about that.
Excellent. Yeah.
And if you have a GitHub link, we'll share that also later.
Yeah. Okay. All right. So I tried to put notes as adequate as possible. What is this about? But I will explain again. Like the first thing that you need to put is the wire.h, because you're going to use the I2C protocol. And then you need the library for the MLX90614, which is the sensor over here. I took one from Adafruit. How to install this if you don't have it yet? You can go to this Sketch, include library, and then manage library. All right, and you can search for. I think sometimes. Okay, it's ready now. Okay, MLX, and you will have a list of MLX, and you choose this one. Oh, sorry, you choose this one. MLX 90614 library. Of course, it depends on your sensor. Yeah, if you got a mini, then you can get a mini. If you got the normal one, then you choose this one. right? Once you install this, then you can use this library here. Otherwise, when you compile, it will give you an error because it says MLX90614 library is not installed. So you make sure that you have installed this first. Okay. Now, you need only two variables in a float type. So you can have a floating point. You have decimals. Two variables. One is for the ambient temperature and one is for the object temperature. Yeah, I forgot to mention that this temperature sensor, this sensor can sense two types of temperature at one go. One is the ambient temperature, which is the surrounding. Second is the object temperature, which is in front of it. So you don't have to have two types of sensors. One sensor will measure both object and the ambient. And we define the loop interval 500 millisecond. Sorry, this is about actually 5 millisecond over here. If this is too fast, we can do it like every 1 second. Yeah. Every 1000 millisecond, which is every 1 second. And then we define this sensor first as an object. So Arduino used the C++ like code, which is object oriented. So we define this sensor as an object. And then as every other Arduino code, it starts with the setup. It says MLX begin, okay, this object to begin. And you also want to begin using the serial port at this speed. And just give some times for the machine to set up. Some modern machine, you don't even need this delay. And you start reading it. It will start reading by issuing this command. Like this is not actually a command, it's object-oriented, so it's a method. Yeah. MLX read object temperature in Celsius. If you want to measure in Fahrenheit, some of you might be from US, I don't know. That's the only place that uses Fahrenheit. You can change this to F. But in the UAE, in India, in Indonesia, in Germany, in Europe, most of them using Celsius. So let's do this. We read both the object and ambient and put them into their respective variables. Okay. And we don't have a display yet at this point, right? Remember, we only have sensor and Arduino. So where are we going to see the result? We want to see the result on the serial port. So we do this serial print ln to go to the next line after that. The object, and then the value, and then the ambient, and then the value. Okay. All right. Let's try to push this. Okay. This is a live, not recorded, so anything can happen. Usually it works, but sometimes things doesn't. Okay, it's done uploading. So let's check our serial monitor now. Okay. Okay. It reads. Okay, you see there's this object temperature and ambient temperature. So how do I make sure that it's reading an object? Okay, I'm just going to put the screen on the desktop. Okay, I put my finger here, so you can see that I put my finger here. Do you see the temperature increase? It's now 27.4. Okay, maybe I put the, let's try. Put my coffee here. My coffee is cold already. Okay, maybe I put my forehead. Okay, it's a bit higher now, 29. Okay. However, this, of course, it doesn't show accurate temperature, right? As what Amit has mentioned earlier, how accurate it is. So we need to calibrate. Okay, if my body temperature is normally 36.5, 36.6. Well, we have to measure using a real thermometer now. So I'm measuring a temperature, and I'm going to use the result to calibrate this thermometer. Right? Okay, you got the result now. 36.9, 36.9. Okay, a bit high, maybe a bit nervous. It's in front of camera. Let's put this away a little bit. Okay. So what I'm going to do now is I'm going to modify the code. Earlier we saw that the object, if I put my forehead like this, is about 28.9, 20, 29. Okay, let's put it 29. Yeah. It's 29, but my actual temperature is 36.9. Okay. Here is like a 28.9. So it has an offset of about 8 degrees, right? So what I need to do now is here, I have to add by 8. What about the ambient temperature? I don't have to add 8 because ambient temperature is what it sees around it. So it's supposed to be correct. The object temperature is the one that is in front of it that is changing. Okay. And looks like I'm missing something, like, oh, I missed the C over here. Yeah. Our friends from the other part of the world might get confused. What number is this? Okay, it's a degree Celsius. So I'm going to put over here C, and I'm going to put over here another C. All right. If you get lost a little bit, when you watch this recording, you can always reply this. Okay, let's push this again to the Arduino. Uploading. Done uploading. Okay, let's check the result now. Okay, you see, the object now is representing a closer number that is closer to the reality. Yeah. So I will put this to my forehead again. Let's see. Okay. Okay. It's 36.7, 36. Okay. Right. It gets closer to the reality now. However, we still have problems here. What's the problem? If I put it close and I put it a bit far, the result is different. If I put it close, it seems hotter, isn't it? If I put it far, if you put my hand far, the temperatures drop. The temperature drops. So I think we have a problem if we don't compensate this. I'm going to go back to my presentation here. All right, here. But before that, we forgot. We need to put the display, right? Yes, we need to put it on the display. Okay, so what we are going to do now, we're going to connect the display. Before we do something else, we're going to put the display, and first of all, I have to disconnect this. Always disconnect the power when you are rewiring your circuit. Otherwise, you might get short-circuited. It may damage your board. It may even get you electrocuted. So please always disconnect the power display over here. Okay. Let's put it here. Okay, let's say over here. Now, I don't need any other connection to the Arduino board, as we mentioned before. We are going to use the I2C protocol, I2C wiring, to connect to the same wire here. Okay, first, we are going to connect the ground and the power, the positive. So ground in this display is the leftmost here, probably not very clear, but I can see it here. All right, this is the ground. Okay, you're going to connect to the ground, which is this one, in parallel. I assume you already know how breadboard works, right? all of this line here, they are interconnected. This interconnected, but this and this are not connected. This and this and this and this, they are connected. So when I put like this, means the wire here, the black wire and this black wire is connected. All right. Second is the power. I'm going to connect the power here. This is the positive, right? Okay. What is left now? Okay. The SCL and SDA. All right, let's start with the SDA. Do you still remember SDA? SDA is 4, right? A4. 4 looks like A, so it must be SDA. So I put it here. SDA is, in this case, is here. All right. I use the same color of wire, so it's consistent like a blue. Blue is for SDA. And then for the wire, does not affect the electricity current or whatsoever. It's just helps you to make sure you wire to the right place. And it's also, to some extent, it's a pleasure to die if you have a nice wire color. Okay, now I have the display. But this display will not work. Why? Because we have not programmed it. If we connect this, right, it works now, but I mean, the sensor is working, but this display is not working. Okay, let's go back now to the Arduino. See, it's still working, right? But the display is not working. So we are going to make it work. I already have a sketch over here that already have the OLED in. Okay. You see the highlighted part in yellow? This is the additional part that was not there in the original code. So we have this already. We have this before. Now we need more library because we use this. We are using this display over here, which is called SSD1306. So again, we need to install the library for that. Manage library again, and we are going to search for the library for that part. Okay. In my case, it's already installed. For you, you can do an install, and it even suggests the update if there's any new update. Okay. Once you install, then you can use this one. Otherwise, it will give you an error when you're compiling. So make sure that you have installed the necessary library. Okay, so we're going to close this, and we're going to continue with the explanation. We define the screen width and height in pixel. Okay, so width is 128, the height is 64. So over here, yeah. Okay, so this width is 128, this is 64. We need to remember this because when we program this later, we have to remember where are we going to put the characters. We are going to put the pixels. Okay, let's move on. The loop interval, again, I think there's some mistakes over here. Let's correct this every 1 second again. And then remember, we have done compensation in the earlier experiment, right? We need to add number 8 over here to make sure that the temperature that is displayed is according to what we have. Okay. And this remains. We still want to log to the serial port. And we also want to show it on the OLED screen. And this is how you can show it on the OLED screen. First, you issue this clear display. Oh, one thing, sorry, almost forgot. In the serial begin, you have to add this line. Display begin SSD1306. Okay, how did I come up with this? I got it from the example. Right? This is how I learned. I learned from other people who already done it before, and then I tried it. If necessary, I have to make some changes. In this case, for example, I changed the address of my display to 3C instead of 3D. Okay, because the code that I was taking from the internet, they used a display that looks similar but slightly different in terms of the address. Remember the I2C explanation over here? Yeah, this is the address that I mentioned before. If you point to different address, then it won't work. You won't see the difference because it's addressing the wrong device. So make sure that you address the right device. How do you sure that you can address this, for example? This is the correct address. Well, you can look at the data sheet. Otherwise, you can also use a program called I2C scanner. Okay, you can use a program called I2C scanner that will help you to find the address. So how to use this? Just run a program. It's also on Arduino, so I have it over here. I have a lot of programs. There's the I2C scanner somewhere. Yeah, I2C scanner. This will find the device that is connected to your I2C interface. I suggest when you do this, you connect only one device at a time. Connect only one device, let it find what is the address. Otherwise, if you connect several devices at the same time, then you get confused which one is which, right? So one by one. Okay, then you do this clear display to make sure the display is clear and set the text color to white. The display that I'm using has two colors, yellow and blue. However, I cannot control the color. It's just what it is. Like the first 20 pixels is always yellow, the rest always blue. So it doesn't matter what kind of color I specify over here, it will come up just like that. However, I found that if I remove this line, I got a blank screen. So I leave this line over there. Okay, let's go back to how to show on OLED over here. Starting from this line, clear display, set the text size to 1 to make it small and say Arduino thermometer. Okay, text size 2 means it's bigger font and it will show the TO or temperature of the object. And then the next line over here, if you see 0.40, so I go like a 20 pixels in between, okay, to give the height, because the height of the character is 16, then I leave about 4 pixels as a space. And display it. All right, and then delay for a loop interval, and it will go on and on again. Okay, let's try now. We're going to push this, compile, and upload to the Arduino, and hope it works. All right, uploading, done uploading. Now we are going to see if it works. Oh, okay, it works now. All right, I'm going to maximize this. Okay, it's probably flickering a little bit, but you see now the result is there, displayed on the screen. So how easy was that? Very fast, right? It's very quick. If I put my finger on top of this, you see the temperature of the object is increasing. Okay, it's pretty much resembling my current temperature. Probably I have pulled down a little bit now to the 6 point something. Yeah, 36.5, 36. If I go a bit far, bit further here, I put my finger, let's say, a bit far. The temperature drops to 35. If I go further again, temperature even dropped 35.5. Yeah. Okay. So we know that the distance.
Just to interrupt.
Yes, go ahead.
I was just curious also, is the temperature changing as per the distance, or is it like as you're getting closer? Is there can we say that the distance is affecting the accuracy of the reading?
Exactly.
Or is it supposed to do that, or is it just like, as long as it's in the range, it'll be fine?
Okay. So as mentioned, if this kind of sensor has this characteristic, the result you can always repeat, but it's not showing the accurate value. Means that we have to always compensate, depends on the distance. Maybe certain range of distance, like within the same, within the range of 5 centimeter, you can still see the similar result. But when I go much further, then it's not showing a very big difference. So yes, it's the characteristic of the sensor, which I will explain over here. Here.
Okay.
Okay. The industrial thermometer use the same principle, right? So when the distance is close, it measures a very small area of the object. As you go out, it's like when you turn on your flashlight, that torch. As you go out, the beam will go bigger, right?
Okay.
So that kind of area is the area that you're measuring. So imagine if you put it close to your skin like this, it's probably only measure this part. But as you go, it measures also others, which means the temperature on my eyes is probably different with on my cheek. It probably also take a temperature of my hair, which is definitely cooler than my skin, right? And it still does not reflect the true temperature of my body, because what we are interested is the temperature not of my skin surface, but what is inside. That's why when I use this a real thermometer, the industrial thermometer, I have to put it in my mouth because that's what I want to measure inside my body.
Correct.
And that, the baby temperature, they need to put it inside the ear to make sure that it measures the inside body of the temperature. So how to compensate this? Well, as long as we can become consistently putting compensation value, like what we did just now. Let's say we know that the difference is about 8 degrees Celsius. We can put in the formula in Arduino that at this distance, you have to add this value to reflect the true temperature.
It becomes more of a variable, like it's something that it's calibrated on its own.
Calibrated. So calibration, you spot on, Nikhil. The calibration is what the important part in using the sensor, because it happens, in many places. I got this circulated on a WhatsApp group, like somebody said, "Sir, you are good. Your temperature is 32." They use this gun thermometer, they snap and beep, 32. Good, sir, go. If your body temperature is 32, you're a zombie, right? Yeah. You're dead.
It's uncalibrated.
Our body temperature cannot go very low, that low, right? It's hypothermia, very acute. So this is because of that kind of a wrong way of using the thermometer. Maybe this guy is so scared, so he go like not close enough, close enough, and then got the wrong reading. Okay. So
I'll let you get back to it.
Yeah. Okay. So I took this from the data sheet. Maybe I can go to the real data sheet so you can have a better view over here. All right. So this is the data view. Yeah. The data sheet of that temperature sensor. In this family, it can measure a high range of object temperature. So not only to measure your body temperature, it can also measure ice, molten lead, for example, a lot of stuff. Right? It's very powerful. The accuracy is 0.5 degrees Celsius in wide temperature range. Okay. So now we know the accuracy of it. However, you see, there is something called FOV over here. Let me just make it bigger again. Okay. It comes in 3 packages. So apparently, this sensor is manufactured in 3 different classes. The standard package, in the package C, which has a 35-degree FOV, like field of view. How wide is the view? Yeah. Obviously, the smaller the FOV, the more accurate it is. Like one spot like this, the type E, the package option I, this I, has 5-degree FOV. Right? The field of view is very small, 5 degree, and the least is this type C, which has a wide FOV. So it depends on that, and you have a different kind of effect, but need not to worry about this. Calibration is the key. And our students in third year engineering has a lot of work in this. So they understand very clearly that, yes, there's no sensor that is accurate. There's no sensor that's ideal. All right. That's why we need to apply something that makes it more readable, makes the result more trustable. Okay, let me go back to the slide. So how to do this? We are going to add a distance sensor. In robotics, this is called sensor fusion. So you combine 2 sensors to make the value more accurate or more trustable. Yeah. How are we going to do this? Okay, we already have the temperature sensor over here, measuring an area of your face, for example, in this case. Yeah. And we're going to add a distance sensor to measure how far is your face from this system that we are going to build. Okay, so it will look like this. Yeah. So you have temperature sensor over here. You have we use the ultrasonic sensor because that's what I have ideally. Ideally, you can use another infrared ranging. Like I remember Simon has made this theremin, the musical instrument that you can do like this, that connected to LED, right? So that's a ranging sensor that measures the distance between that sensor and the object in front of it. You can use the same one, and that is more accurate than an ultrasonic sensor. Okay. What this ultrasonic sensor provided is the range. However, there's a problem. The problem is the ultrasonic sensor sometimes it got reflected. Like our face is not perfectly flat, right? Ultrasonic sensor is good to measure something that is perfectly flat, like a box, or a bigger object like a car. That's why you have ultrasonic sensor in your car bumpers. But when you measure the face, like my face is not perfectly flat, definitely nobody does. It may got reflected, like when the ultrasound comes to my face, it may got reflected, right? Maybe from the nose, from here. So sometimes it's not very accurate. However, I found that if we are close enough, like about 30 to 40 centimeter, this problem happens less often, and we got a better reading. So that's why I come up with this distance, about 30 to 40 centimeter. Okay. The idea is I can hang this on the wall. I can just go close to the wall, and then I just stand about 30 to 40 centimeter from the wall. I got the reading. I got it there. Okay. All right. So we are going to modify now our code to include that kind of sensor. Okay. First, I have to disconnect this. I have to switch back to the camera. Yeah. Okay. Just a minute. I need to connect to that camera. Okay. The thing is now I have already another setup already wired. I have ultrasonic over here, and I have the display. I can put it over here. Yeah. So this is the SDA and SEL that is connected to the A4 and A5 of the Arduino. All right. This is the ultrasonic sensor, and we're going to put the temperature sensor. I'm going to put it over here. Oh, okay. You cannot see why I want to put it over there. So I have to remove this first so you can see. I do like some internal wiring to make sure that it's not cluttered. Yeah, that's how I like to make my circuit. It's not very cluttered. Sometimes I use small wires like this just to make sure that it's connected, but you don't have a lot of wire going out and in. Okay, so this is my temperature sensor over there, and this is the ultrasonic sensor I put over here. Okay, so it's pretty neat now. We are going to connect it. Okay. All right. So I have programmed this. I will explain to you the code later, but since we are on this view now, I'm just going to explain. You see, it says too close. Too close, yes, because maybe there is a camera on top of it. It says get closer means I'm too far, so I'm going to put, okay, too close. Okay, maybe about this distance is just nice. It shows my temperature is 36.4. Okay, it asked me to get closer again. All right, 36.6. Yeah, that's about right. Probably if I measure my temperature. So while we are doing this, I'm going to measure my temperature again. Okay. Let's see, it's pointing to my face now. It says 37, and let's see, it says 37. It says 37 here was 37. Okay, 36.9, 36.9. Okay, maybe closer a little bit, but it's close enough, right? So I can say that, okay, this value is trustable. It's believable. It's not like in the beginning we got like 28, 29 degree, which is impossible, right? So apparently this ultrasonic sensor helps. It helps to make sure that I'm on the right distance. So if I got too far, it will say get closer. If I'm too close, it says it's too close. If I just move my head a little bit away, and it will say, okay, I'm on the right distance. And as I mentioned, sometimes the ultrasonic signal got reflected left and right, so that's why it cannot get my range correctly, but more or less, okay, sometimes it's stable now. So this way you can hang this device on the wall, put it on the wall, and then you can anyone just go pass by and read your own temperature without have to do anything. Just stand over there. Maybe you can put a sign like stand about 30 centimeter away, or put on the floor like what you see in a supermarket nowadays, a place indicating where to stand. Stand over there, and yeah, probably a little bit problem because people's height are not the same, right? Some are tall, some are not that tall. So you can put it on a medium height, especially if you have kids around. And you just duck a little bit. It's fine. It's still about the same distance because it will tell you anyway if you get too close or if you are getting too far from it. And it will give you a reading that's already calibrated and show the right number. Okay. Now you probably want me to explain how the code works. All right, so I'm going to go to the code. Nikhil, how long do we have? How much more time do we have?
I think we can probably wrap up in the next 5 to 10 minutes.
Okay, I'll just go very quickly then about this. So the difference that I have over here is I have added a liquid crystal also to make sure that this this liquid crystal works also. Okay, I can demonstrate that later, but let me go through. Okay, so you are familiar, most of you familiar with the ultrasonic, how ultrasonic works. So it will trigger an ultrasonic sound, and then it will measure the time between this triggering time and the time that this ultrasonic sound gets back to it. Based on that time, you can measure the distance and divide by 2. Why 2? Because the sound will travel out and back, right? And you want to only measure the distance between you and the object. Sorry, between the sensor and the object. So these lines explain on how to measure, okay? And this is the limit that I put. So if you go closer than 30 centimeter, it will tell you go back, okay, move away, you're too close. And if it's 40, more than 40, it says you're too far, please come closer. Okay, and this is how we trigger the ultrasonic. This is the display that we showed before. And this is again the ultrasonic triggering, and this is the calculation. There's a formula that's already there, okay, based on the speed of sound. So you got a distance in centimeter, okay. And then in my calibration, if we go about 30 to 40 centimeter, my compensation value is 8.5. Earlier, we saw that it's using 8, right? But 8 is if I'm very close. If I'm very close to the sensor, like a 1 centimeter, 5 centimeter, that kind of range. If I go further, about 30 to 40 centimeter, I need to put 8.5. Okay, as usual, for the ambient temperature, we don't have to compensate that. And we still print to serial just for debugging purpose to make sure that it works. Okay, this is where I put the get closer and too close message. I put it on the first line, okay, which so happened in my display is in a yellow color, right? See that? Okay. And then we have to close, and if the distance goes right, okay, let's see if it goes right. It's too close. Okay. Okay, if it's right, then it will display the temperature. So you will see over here, this is the one that is doing that. Okay. If you notice, the font is a bit bigger when it's showing the right temperature, right? 36.1, yeah. Because I set the stack size as 3. Usually in previous one, I put it as 2. And there are some small words over that you cannot probably see it very clearly, but it's showing the distance and the ambient temperature, which is defined by this line over here. The display print and ambient distance and ambient. Okay. I also send this information to the LCD, like Nikhil asked before. Can we display it on other than OLED? Yes, we can. We can put it on other display. Can we have it concurrently? Yes, we can. Okay. Let me just disconnect this and let me attach the liquid crystal display. Yeah, this one that is already fitted with the I2C interface. Okay, as usual, positive to positive, which is this one. Okay, oops, sorry. Brown to brown to ground. I like to use either black or brown to ground. It's just rhyme well. Red to positive. It doesn't rhyme, but that's how it is. Okay, and then SDA. SDA is this. This time I'm not very consistent. And SEL is this. Sorry. Let me check quickly. I hope it works. If it doesn't work, means I put it wrongly. Okay, let's see. Okay, the LCD turns on, but nothing is showing up over there. Means probably I put the wire the other way around. Okay, let's just try. Disconnect and swap this SDA and SEL. Let's see. I hope it works this time. Okay. Still not working. Something is not right. Probably. It's very faint, actually. Not sure why. All right. So, I think we are running out of time. So, we're just going to use this for now. But it is possible. It works before, as usual. When we have a demo, usually things don't work. If you have any question before we conclude this session, please feel free. Nikhil, maybe you have more questions from the forum?
I'll just check. So, Professor Judhi, we do have a question from Shubhan Bhatia. He's asking, how is the infrared thermometer affected by proximity to a radio frequency with a relatively high electromagnetic field strength?
Okay, I think this is not affected. It's not affected. Why? Because infrared is in the color spectrum, right? In the visible, it's invisible, but it's close to the visible light. While the radio frequencies such as mobile phone, microwave oven, Bluetooth, Wi-Fi, all of these are in the radio frequency spectrum, which is very far away from the color or the light spectrum. So it's not affecting at all.
Okay, I hope that answers your question, Shubham. I'll let you get on with it.
Yeah. If there's any more question?
Nothing at the moment, no.
Okay, so I hope everything is clear. So we can make our own, let me go back to the presentation to conclude this. It's not very accurate, but they are consistently inaccurate. So we need to make a compensation. Right? The reading varies on the distance. If you put different distance, it will read different temperature. So you need to add a compensation. And adding a sensor, which is a distance sensor, in this case is ultrasonic, will help to improve the accuracy. Okay, and making our own temperature sensor, our own thermometer, it turned out to be not very complicated. But to make it work with high accuracy, it requires extra effort. Adding a sensor, doing a calibration, doing some experiment like what I did. Actually, I have this. Put it on Microsoft Excel. Let's see how it's covering it. I'm not sure why it's not showing. Okay, so this is how I come up with this distance. I did several experiments like with different distance. How does this affect? Um, and it turned out that, okay, if the distance variations is about 10 centimeter, it does not affect so much. So this is how I come up with this idea of about 30 to 40 centimeter, considering the accuracy also of the ultrasonic sensor and the contour of the face that might be affecting. So, but however, although you already have this thermometer, if you are not sure, let's say you got like 37.5, which is like the limit of considered a fever, and you have cough, even though you don't have fever, or you have a breathing difficulties, please go and see doctor. Don't risk anything. Okay, this thermometer will not stop you for catching a virus, but it will just help you to monitor your body temperature, which sometimes is linked to that, but not always. So never use only this one device as what we use with the temperature sensor combined with the ultrasonic sensor. We use something called sensor fusion to detect more accurate things. So similarly, you don't make those things just rely on one device. Don't rely on one opinion. Always seek doctor's opinion if you feel sick,
Of course.
or not well.
That's
Okay.
always the case. This is a nice feature. So I think that's about it. We've covered all the topics there. We will share all the code and everything for people to use. We'll update it in the description on YouTube, plus also share it on social media. Once again, thank you so much, Professor Judhi. I'm going to
Hey, come on
Professor
again, just Judy, please.
I've got so used to it. I have to say that, but I appreciate it. I hope like all of us, we are staying at home, so it's good that you're sharing knowledge while we're doing that. It's important to know what's going on under the hood of all these things. It's important. Like these are strange times we live in, but we have to make sure that our learning keeps on going. I just before we sign out, I wanted to thank you. Your students, I'm sure you'll be back to. When is your next teaching session? Is it today itself, or are you off for the weekend?
Okay. Thank you. Thanks again, everyone, for joining us. Hope you stay safe. Stay at home for now. Be creative and keep on inventing. Okay.
Absolutely.
Have a good day.
Thank you, Judy. And just to let you know, also next week we are of course going to keep on with the weekly sessions as well. We are also going to keep pushing our content throughout the thing. Obviously, now people are at home and they don't just have to wait for the weekend to consume content. So our team is working continuously to build up content that we can share. We will also share some content throughout, shorter bits. We will try to do something more interactive. Next week, we're still finalizing the plan and the platform for that. This format we will use from time to time, the one that we've done now, but we will try a few different formats that might allow for more interaction. Next week, we'll be doing something DevOps related. Again, we'll have a guest who is connecting. In fact, I think at this moment they're out of the country, but they will be connecting remotely, and we will let you know how to work with that. So just to give you a quick sneak peek, we will be working with GitLab in that, a little bit of Kubernetes. Obviously, we are going to keep it short, so maximum an hour and a half, but we will try to find out a more interactive format, and we'll get back to that. So again, thank you, Judy. And from us at the virtual assembly today, just wanted to say bye-bye. See you, and thank you for attending.